So hi guys, we are at day 15, the final day of dynamic programming series, and the problem that we are going to discuss today is Leetcode problem, that is make array strictly increasing. So let us look at the problem statement. So basically in the problem we have been given two integer arrays, that is array 1 and array 2, and we need to return the minimum number of operation that can be possibly 0 needed to make array 1 strictly increasing. In one operation you can choose two indices, that is I from array 1 and j from array 2, and what we can do is we can assign array of 1 with array of 2 from that particular ith and jth indices. So if there is no way to make array 1 strictly increasing, then what we need to do, we need to return -1. So I hope the question is clear. So let us look at the example of the question, that how we can do this. So basically if array 1 is given like 1 5 3 6 7 and array 2 is 1 3 2 4, so what we need to do is we need to make array 1 strictly increasing from any of the elements, possibly 0 from array 2, by replacing the values. Okay, so what we can do is, let us see that is array 1 increasing or not. So what we can see, that 1 and then 5 is increasing, that is 5 is greater than 1, and after 5 that is 3, so 3 is less than 1. So here 5 need to be replaced such that the array 1 could be increasing. So how we can replace 5? We can replace 5 with the 2. If we place 2 here, then the array 1 becomes 1 2 3 6 7, that is increasing in all domains, right? So 1, then 2, then 3, then 6, and then 7. So it is strictly increasing. And how many operations do we require to convert this? Only one operation, that is putting 2 at the place of 5 in this array 1. So this is possibly the question, and we need to return the minimum number of operations that is required to convert array 1 strictly increasing. So now let us look at the approach towards this problem. As far as in this DP series, what we try to do is, first what we will do, we will develop the logic, then build a brute force or the recursive solution, and then after that apply dynamic programming on that brute force solution. Similarly we are going in this question also. So let us see how we can do this. So what we need to do is we need to make the array strictly increasing. For any position I in array 1, there is two positions, that is I minus 1th position, the position which is just before the ith position, and I plus 1th position, that is the position after the ith position. So for any ith position we need to consider two possibilities. The first one is array of I is less than equal to array of I minus 1. So the value at this position is less than the value at this position. And the second possibility is array of I is greater than array of I minus 1, that is the value at this position is greater than the value at this particular position. So we are considering two cases. One is that this value is less than equal to this value, or this value is greater than this value. So we'll analyze these two different cases. So let us analyze the first case. If this value, the value at ith position, is less than equal to that I minus 1th position, that means we need to replace this value from array 2. Why? Because it makes the array decreasing. If this value is greater than this value, that means the array is decreasing here. So we want the array to be increasing, so we'll replace this value from array 2. So now the question arises that from which value we need to replace. Let us look. Suppose we have array 2 like this, a b c d. Suppose these are some values. So if a is greater than array of 1 I minus 1, that means the I minus 1th value from array 1 has been selected, and there are two values in array 2 which are greater than these values. So we can choose any value among these values, but what we will do is we will choose the minimum of these two values. Why? Let us look with the help of an example. Okay, so if we have this array 1, that is 1 9 4 5 and 6, and if we have this array 2 2 8 12 13, so if we arrive at this particular position 9, that is the ith value is 9. So till now the array has been increasing, but now after that the array declined, so we need to replace this value 9. So how we can replace this? We'll look at the array I minus 1th value 1. So how many values in this array are greater than 1? That is all the values, 2 8 12 13, all the values are greater than 1. So can we apply any value there? No, we need to apply the value which is just greater than this particular value, that is 1. So that is 2. So we'll apply 2 over here, and then the 9th value, the 9th position, the value at this particular position will be 2. So now the array will be 1 2 4 5 6. So what will happen if we apply 8 over here, since 8 is also greater than 1. So if we apply 8 over here, then the whole array will not be increasing. It will first increase till 8, then after that it will form a decreasing structure, that is 8 is greater than 4. So we need to see that we need to take the value which is just greater than array of I minus 1, right? So here in this case, the value which is just greater than is 2. So for this, what we can do is we can just sort the array 2, and after applying binary search of searching this element, we'll get the value which is just greater than the particular value, I minus 1th value. So I hope this concept is clear over here, that why we are selecting just greater than value from array of I minus 1th value. Okay, so the first case is very clear, that if the value of array of I minus 1 is greater than equal to array of I, then what we need to do? We need to replace the value from the value which is just greater than the ith minus 1 value in array 1. Okay, so now let us look at the second case. So second case is array of I is greater than array of I minus 1. So that means till here the array is increasing. Till here the array is increasing. So what we need to do, we'll continue. Simple, let it be this value remains over this position and we'll continue. So the one possibility is that we need to continue, and we do not need to disturb this value. So there is one possibility. Now the second possibility is also there, that we can replace this ith value. Now the question will come in your mind, that why we need to replace the value if the array is already increasing till here. So why we need to replace the value? Let us understand with the help of an example. Suppose we have the example, array 1 is 1, 2, 100, 5, 6, 7, and array 2 is this given 3, 101, 102 and 103. Now what we do, we'll traverse from 1, so we'll find it increasing. Then what we'll do, we'll traverse to 2, we'll find it increasing. And then what we'll do, we'll traverse to 100. So 100 is also greater than 2, so it is increasing. And then what we'll do, we'll find 5 over here. So 5 is less than 100. So we need to change the value of this 5. Okay, so if we'll change this value, so what we'll select? We'll select 101, because the value which is just greater than 5 is 101 here. So we'll replace it 101. After that, what we'll do? We'll replace 6, that is 102, and I'll replace 7 with 103. So 3 values have been replaced over here in this particular case. So the operations required are 3. But what if in the previous case, if we replace 100 with 3, we can replace 100 with 3. So if we'll replace 100 with 3, then in only one operation we'll find the array increasing. That is, if we place 3 over here over the place 100, then what we'll find? 1, 2, 3, 5, 6, 7. That is a increasing array, and the number of operations required is only 1. So in one operation we have find the increasing array. So there are two possibilities that can arise. First is let the number be and continue to the array, and the second possibility is replace the element from the second array and just continue it. So in this particular case, if the value array I is greater than array of I minus 1, then there are two possibilities. We have understood all the possibilities till now. So this is how we will develop a brute force solution over these two possibilities, and we'll form the code. But this code will be time consuming, because here we are making recursive call again and again. So in this particular code, after developing the logic of the brute force operation or brute force approach, what we will do is we'll try to develop a dynamic programming solution with memoization. So now let us understand how we can apply dynamic programming with memoization in this particular recursive or brute force solution that we have developed. So getting the states of memoization. So if you have not understood what states means, you can watch my previous video of dynamic programming series. I have explained state of dynamic programming in these videos, so I'll give the link in the description and you can watch these videos. So in this problem, what we are trying to do is the I represent the ith value of that particular index, of which we are considering the minimum number of operations to be found out. Okay, and the L represent the left value. So what can be the left value? Left value can be the value which is just before it in the array 1, or it can be the replaced value, the value which we need to be replaced from array 2. So there are two cases in this particular problem. The value can be the replaced value or the value just before the ith value. So what is dp of I comma L storing? The dp of I comma L storing is the minimum operations required till ith with left of array 1 as a value L. So if the value of the left of the array of 1 is L, then what are the minimum operations till ith that we can get? So this is dp of I comma L is storing. Now let us look at the example that how we can apply this particular problem in this example. So if we have been given array 1 like 1 5 3 6 7 and array 2 as 1 3 2 4, so how we can apply this solution towards this example? So we'll traverse the array 1, and what we need to do is we need to compare it with the I minus 1th value. So if at index 0, how we can compare it with the previous value? So what we'll do is we'll store array of 1 minus 1 with minus infinity. Why with minus infinity? Because we'll consider two cases at index 0, that is if it is replaced, or what we'll do is we'll continue. So in which case there are two cases possible, the replacement also and the continuation also. The case in which the array of ith element is greater than array of I minus 1 element. We have seen in the previous part of the video that two cases are possible in this particular case only. So what we'll do, we'll store array of minus 1 as minus infinity. So now let's move forward. If we move forward, then what we'll do, we'll find 5. So 5 is greater than 1. So let us suppose without replacement we'll move forward for 3. So here if we are on 3, so we can see that this value is less than this I minus 1th value. So what we need to do, we need to do a replacement. So what we can do, we'll find the value which is just greater than the I minus 1th value. The I minus 1th value is 5. So we'll find the value which is just greater than this 5th value. So any value which is greater than 5, there is no value which is greater than 5 in this particular array. That means no possible configuration exists in this particular case. So what we'll do, we'll just traverse back, and if we'll traverse back, then what we will find that can we replace this 5 with any value? Yes, we can replace 5, because the I minus 1th value is 1 and the value which is just greater than 1 is 2. So if we replace 5 with 2, then there is a possible configuration which exists, that is 1 2 3 6 7. So we'll replace this 2, we'll replace this 5 with this 2, and then we'll get a increasing series, that is 1 2 3 6 and 7. So in one operation what we can do, we can achieve a strictly increasing series. So this is how we will develop and we'll form this solution. So now let us move on to the coding part, that how we can form the code of this particular problem. Understand the code, very important. It is very important to understand the code, because there are some hidden concepts also in the code. So let us try to understand the coding structure of this problem. Okay, so now let us look at the solution of this particular problem. So the solution is in the C++ code, and we have been given a make increasing function, and we have been provided with two vectors, that is array 1 and array 2, as discussed in the problem. So as we have developed the concept, so first what we will do is we'll sort the array 2. As we have seen, we need to find the values in the array 2. So what we will do is we'll sort it. Now what I have done is I have made a vector of unordered map, that is integer comma integer. So why I did that is, in array what we can do is we can store the values, but in this particular problem what we have is we can also have a negative values also. So for the negative values, if we need to have the indices for the negative values, we cannot index in array for any negative value. So what I did is I made a unordered map for that. So it is a good practice to get flexible to these data structures. Okay, so if you are not aware of this unordered map, you can always search Google for what is unordered map. Now I have made a 2D array, 2D matrix of unordered map vector, that is of length 2001 as given in the constraint of the problem. Now I am solving the check function. So what is in the check function? First what we are getting is a current, that is a current index that we are onto. The second is the left value, the left value of the current index. The third value is the array 1 that we are getting, the vector of integers, and the fourth is also the array 2, the vector of integers, and the fifth is the DP array that we are getting of unordered map vector. Now what is the first condition is, if current value is equals to array of size, array 1 of size. So if we are at the last point, then what we need to do is we need to return 0, because after that there will be no checking for whether the value is greater or not. We have checked all the condition, and if we are at the last point of the vector, then what we need to do is we need to return the 0 according to the base condition. Now what is the second condition? If dp of current dot find left is not equal to dp of current dot end, then what we need to do is we need to return dp of current left. As we do in dynamic programming questions, that if we find the value of dp of current for any position left that we are searching on, if we get the value not equal to dp.end means that we are not at the end, we have found the value, then what we need to do is we need to simply return the value. So why this condition is helpful? Because we are not trying to again and again make the recursive call for the value which we have calculated earlier. So that is why we have made a dp array over here. Now what I am doing is I am making two variables, that is rest1 and rest2. So if array of 1 of the current value is greater than left, that means the value at the current index is greater than the previous value, then what we will do, I'll store it in rest1 and I'll make a recursive call on the continuation index, that is I'll increase the current index and make a similar call on the further index. So as we have discussed, if the value is increasing, then what we can do, we'll either make a continuation request, either we'll continue the whole array, or what we can do, we'll replace. So replacement will be in rest2 part. So what we will do is we'll replace the value in rest2. In rest1, what we are trying to do is we'll trying to get the value of the continuation process, that if we increase the index, then what will happen. So if the value is greater than the previous value, then what we'll do, we'll make a recursive call. If not, then what we'll do, we'll store int max in rest1. Why? Because there is no continuation left. So in this case, what we need to do, we'll only need to replace the value, and replacement value will be stored in rest2. So rest1, what will have it, will have int max. Why? Because at last we need to take minimum of rest1 and rest2. So the rest1 will store the maximum integer value, and the rest2 will have the replaced value that we need to replace from array2. So let us look at the rest2 part, that how we can replace the value. So what we'll do is we'll make a STL, this upper bound function, STL function. So what this function return is, we'll pass the array and we'll pass the value. So it'll return the index of the minimum greatest value from this particular value that we are passing. Okay, so we'll get the index in this wrap value, and if this wrap is equals to the size of the array, that means the second array size, that means we are at the end of the array, that means we have not found the value. So the rest2 will be int max in this case. And else, if we have the value, if we have found the index of any value which is just greater than the value which we are passing, the left value which we are giving to the function, then what we'll do, we'll make an increment in the current position, and then the left will be updated with array2 of wrap that we are getting, and then we'll make again a recursive call to this check function. So this is how rest2 is working. And at last, what we need to do is we need to check if rest2 equals to int max, then what we will do, we'll make dp of current.left as rest1. So why we did that is because we need to update dp of current comma left with minimum of rest1 comma rest2 plus 1. Why rest2 plus 1? Because rest2 will give the operations till the left value, and the value which is replaced, the ith current value which is replaced, will be one operation. So we'll make rest2 plus 1. So if what will happen if rest2 is int max? So if it is int max, then it will be int max plus 1, which cannot be stored in integer, so it will produce a error. So that's why we have handled this condition here. If that rest2 is equals to int max, then what we'll do, we'll make dp of current comma left is rest1. And at last, what we'll do is we'll return the dp of current comma left after traversing the whole array. So here, like this, what we can get is, this is the main function, that if we'll get the value that is not equals to int max, that will return value in this particular case. And if we get int max from this solution, that means we'll return -1, that is there is no solution possible to make the array increasing. And this is how we'll develop the code for this particular problem. So you can look at this code once more, and you can try to form a solution. You can try to form visuals in your mind that how these things are working and how the problem is going on. So the time complexity of this overall problem is n square log n, because we are considering the states, and at worst we can have n states for the n particular array. So we have been traversing 2D matrix, and the upper bound function take log n time complexity, so the overall complexity will be n square log n. So that's it for day 15, and that is the last day of dynamic programming series. So if you have any questions, you can always ask me. The concepts that we have learned today is dynamic programming plus greedy solution, combined form of dynamic programming and greedy, how we can how we can develop a solution of this problem with these two different approaches, and how we can first form the brute force approach with DP, and then we can apply memoization towards it. So if you have any doubts till now, what we can do is you can comment it in the comment section, or you can send us email on the links that we have provided in the description. So first, please do check the description, do check my previous videos and get dynamic programming better. So thank you for watching. Please do like, share and subscribe.